So all of us make decisions based on some evidence. However, we often pay very little to no attention to the quality of evidence that we use to base our decisions on. So the objective of today's talk is to give you an overview of how we use evidence-based decision making in the context of blockchain to evaluate the validity and the quality and generalizability of the evidence to make better decisions. In January this year, now this is a significant development. In January this year, President Trump of the United States signed an Evidence Policymaking Act, making evidence-based practice a law in the United States. So you can find more information about it in here, but the context of this is that they analyzed 10 projects over a decade period, and they found out that 9 out of 10 projects were not based on any evidence or very weak evidence, and it was costing United States $10 billion a year. 10 billion, not million, 10 billion a year. So over a decade, it costed US economy probably in excess of 100 billion. So what it means is that if you have a blockchain based solution, you have a much better chance of making inroads, making good progress, get approvals, maybe funding, if you can demonstrate that your solution is backed by scientific evidence. So what I'm going to do today is give you an overview of what evidence-based practices, what is evidence-based blockchain, give you some background, why do we need it, what are the 5 steps of practicing EBB, and then summarize it in the end. Now, it's a fact that we are overwhelmed with all sorts of information. Businesses, policymakers, governments, often very confused on what to do with all these opinions. And I'm going to share with you some examples. You see on the screen a very well-renowned economist saying that the enterprise DLT are a fad. Enterprise DLT are a fad. And also in his testimony to US Senate, he also mentioned that cryptocurrencies and Bitcoins is the mother of all scams. Blockchain is a big lie. Now, is this evidence-based? There is a recently there is a research published in the Journal of the British Blockchain Association, which showed that actually the magnitude of cryptocurrency and ICO scams is actually much smaller than initially anticipated. There are some more examples. Blockchain is no good technology. Blockchain is a bullshit. Bitcoin is ridiculous, and so on. There's some more examples. Major consulting firms find little to no evidence of blockchain use cases. And then we have some more kind of opinions from people saying the blockchain will disrupt every industry. It's the next big thing. It's everything. So what do we do with this information? Well, the most important thing is to scientifically evaluate any piece of information that's given to you. So the big question as a business owner, as a CEO, as a government official, what you need to ask is, are these opinions based on facts and backed by scientific data, or are these just opinions? And it should concern you only if you're making decisions. Albert Deming said that without data, without facts, you are just another person with an opinion. So what is evidence-based blockchain? So evidence-based blockchain by definition is a stakeholder-centered approach to conscientious, explicit, and judicious decision-making based on professional expertise and the best available evidence. What does that mean? It means that you take into account evidence from all stakeholders, and then you make a conscientious decision, which means you try. Explicit means you communicate it very clearly, you write it down, and judicious is you make a judgment on the basis of the evidence that you have. So there are 5 steps to practicing evidence-based blockchain. First of all, you ask a very precise question. What is the problem? What are we dealing with? The second is you search for the evidence. What is the evidence? And look for all different sources of evidence. So not just one article or one opinion, but a variety of different sources. Then you critically evaluate the evidence. So you appraise it. Then you apply the results to your practice. And then you monitor any changes. And then ideally, you should document it so that others learn from it as well. Now, evidence-based practice is not a new concept. It's been around for more than 3 decades. Initially started in medicine, and then spread across many disciplines, including social care, nursing, medicine, uh, uh, employment, management, and very recently blockchains. There's a very interesting book I would recommend by Jeffrey Peffer of Stanford University on how businesses can actually profit from evidence-based decision making. And there are many other examples. This is US, Australia, evidence-based policy making. In the UK, we have a Cabinet Office evidence-based policy, European Commission talking about education and training based on evidence, evidence-based policy in Japan, Singapore. There are many books written on evidence-based management, evidence-based practice and action. So this is not a new concept. It's been around for more than 3 decades. Universities are offering courses on evidence-based practice. This is one in Oxford University in the UK, PhD and MPhil programs. We have recently launched a Center for Evidence-Based Blockchain in collaboration with 6 universities, including the Open University, Armit University. These are all blockchain centers of excellence. Open University is the biggest university in the UK. Similarly, we have many different centers. There is an evidence-based cybersecurity in Georgia State University. Conferences, these are different universities participating in blockchain research, education. This is our journal, 3rd issue, and the focus was evidence-based blockchain. Universities are offering courses on evidence-based practice. This is City University of London. This is King's College London offering a course which cost about $1,500 on how to be an evidence-based practitioner. This is another organization which received Queen's Award for following evidence-based practices. There is a Center for Evidence-Based Management at University of Oxford. It's evidence-based policy making. So the question is, why do we need evidence-based blockchain? Well, there are 5 big problems. First of all, we are not very good at asking the right questions. What exactly is the problem? We don't look for the best available scientific evidence. We are not very good at evaluating it, applying it, and assessing it. So this is what evidence-based practice tries to address. So the 5 steps. So let me give you an example. So if you have a supply chain business and you say, well, should I use blockchain for my supply chain business? Well, this is a very poor question, because it doesn't clearly define what is exactly you're trying to achieve. What is the objective? Is it the cost effectiveness, consumer satisfaction? What exactly is it trying to make? Which type of blockchain? In which part of the world? So this is a bad question. So the evidence-based approach is to practice something called a PICO question. So what's the problem? What is the intervention in comparison to what, and what outcomes you are interested in? So this would perhaps be a better question compared to existing traditional database type model. Does private permissioned blockchain, and you can use any different type of blockchain, whatever is you are considering, does that save time, reduce cost, improve integrity, improve consumer satisfaction? If you are interested in tracking seafood, so what type of item you are interested in tracking by supply chain based in India or Brazil or America or wherever. So this is how you clearly define a question. So first step is formulate a precise question. Now, where to search for evidence? I just want to show you this article that I read. It says blockchain study finds 0% success rate. Now, I don't believe in this, but I think what's very interesting here is it says that they tried to survey the several blockchain firms via email, via phone, in person. Not one was willing to share data on program results, and the results include the learning outcomes, the objectives, the goals, etc. So not one. So the thing is that if we don't know what happened to those blockchain projects, how are we going to make progress? How are we going to learn? Now, you may have seen this before. So the evidence, not all evidence is the same. There is some good quality evidence, and there is some not so good quality evidence. So this is a hierarchy of evidence. So starting from the top, you have extremely good quality evidence, which is a systematic review and meta-analysis, taking into account not one but multiple studies. You have original research, interventional case studies, reviews, commentaries, and so on. And right at the very bottom, you can see opinions, expert opinions, ideas, reports, and so on. So you should be making decisions based on good quality evidence, if there is one available. Now, in some areas of practice, there may not be any meta-analysis. There are very few meta-analysis and systematic reviews in blockchain. There's a lot of original research coming out, but there are very few. But nonetheless, if there is one, you should take into consideration and read it and analyze it. Now, where to search for high quality evidence? Now, Google is a good search engine, but it gives you a lot of what I call unfiltered information, which means it gives you everything that has ever been published or available on internet. Google gives you that. So if you are an evidence-based practitioner, you want to search for scientific high quality evidence, you should be looking at places like directory of open access journals, which is I find it extremely useful, because all articles that are published there, we know that they are published in a peer-reviewed journal, because the directory of open access journal don't index any journals which are not peer-reviewed. Similarly, Google Scholar, Semantic Scholar, Microsoft Academic, and so on. This is one of the articles that we published in the JBBA on supply chains, food supply chain, and so on. This is Microsoft Academic, Semantic Scholar, which is Allen Institute for Artificial Intelligence Initiative, and so on. So what are the different sources of evidence? Well, there are four sources of evidence. You have your own personal experience, your organization's evidence, your consortium evidence, and the scientific evidence. Now, your personal opinion, maybe you might say, well, I don't have any evidence, but I have my personal experience. Well, that may be good quality evidence and very relevant, but it may not be good quality evidence and very relevant. We've got Warren Buffett's example. He says Bitcoin is rat poison. It's a scam, it's rat poison. And it's a very poor statement. Which part of Bitcoin is rat poison? Is it the technology? Is it the currency? Is it trading? Is it the peer-to-peer network? So people have these very strongly held beliefs, and sometimes they are very difficult to change. So it's very important to look at other sources of evidence outside your own personal experience or something that you have just read somewhere. So you have organizational evidence, you have evidence from consortium, all stakeholders. Most of the time, these are not peer reviewed. So it's important to look at scientific evidence. Scientific evidence, again, very important to look at peer reviewed scientific evidence. And this is something that we are not very good at practicing. So important to consider. Now, once you have searched for the right information, you got your evidence, the next step is to appraise the evidence. So carefully analyzing, systematically analyze, is it worth it? Is it relevant to my particular practice? Can I apply those results? Is it trustworthy? And so on. And this is University of Birmingham offering courses on critical appraisal, or if you want to learn more. Now, I'm just going to give you some examples of the different the quality of evidence. So are there any meta-analysis, systematic reviews, case researches, original research in blockchain? So there are very few. This is an example from the Journal of Applied Sciences, blockchain applications in education and healthcare. The meta-analysis of blockchain technology for automotive uses, consensus protocols. So very few meta-analysis, systematic reviews. A lot of good research. This is a research from Consensus that we published last year in the JBBA from Peter Robinson. Some case studies, critical reviews, analysis, essays, book reviews, commentaries, and so on. So once you appraise the evidence, now the next step is to apply and assess the results. Why is it important? I think it's very important that even if you have a negative result, it's important to document, it's important to communicate the results so that not only you learn, but also others learn as well. And otherwise, you will end up duplicating and repeating the same procedure, same experiment, and same project again and again, because you don't know what has happened elsewhere. So this is an excellent example of a case study. Blockchains in supply chain reduced the tracking time from 7 days to 2.2 seconds. So now we have an evidence. If you say, does blockchain work in supply chain? Yeah. So we have got a case study demonstrating the effectiveness. This is another article we published, research on Singapore's token offering, and This was also quoted by the US Securities and Exchange Commissioner recently in her speech. What happens if you do voting on blockchain? So it's very, very important that you've done an experiment, you document it, you publish it, and ideally in a peer-reviewed journal so that others will benefit from it. So why are we not using evidence-based blockchain? If it's so good, if it's so beneficial, US president is advocating for it, it's a law in the United States, why is it not so common? Why do we don't use it? Well, I think the first thing is our own beliefs. We have got strongly held beliefs and opinions, sometimes very difficult to change. We don't feel comfortable if they are challenged, and we have blind spots. So very important to be aware, to be conscious of our own cognitive biases. Organizational culture, I think, is another thing. We have always done it this way. Very, very dangerous phrase. I've got a friend of mine who is in charge of one of the largest private healthcare providers in Europe, and whenever I talk to him, I show him the evidence, I show him the systematic reviews, and then he says, no, we are sitting on the fence, and he's been sitting on the fence for past 2 years, and we have got multiple research studies now coming out saying, look, this works. So I think organizational culture is another important thing, and power and politics. We don't the resistance from policymakers is a big one. Whenever you have a disruptive technology paradigm shift, is always challenging to challenge the status quo. People have vested interest in the system, and it's sometimes it's not difficult. It's not easy. So what are the risks of not following the evidence-based practice? Well, I think waste of resources is a big one. As I said before, you can waste billions of dollars if you make decisions which are not based on good quality evidence. If you're a policymaker, it can be a disaster. You may devise benchmarks and frameworks which are ineffective, and 10 years down the line you realize, well, that was not a very good decision. And if you are a blockchain company or a blockchain solution provider, you are better off following evidence-based practice. You have good chance of funding and so on. So how to follow EBB as an individual and as an organization? Well, I think the first thing for an individual is always ask, well, what's the evidence? Show me the evidence. That should be the starting point. Whether you are at a conference, at a meetup, anywhere, always ask why. Why are we doing it? Why do we need this? And question all the information provided to you. Sometimes people have vested interest in telling you about a particular idea, a particular project, and EBB approach gives you this power. It doesn't matter where you are in the organization, what hierarchy you are, whether you are a CEO, whether you are an employee. You can question, you can challenge this project, this idea, this new idea. Is this based on any evidence? Show me the evidence. If you are an organization, I think it's important to follow the 5 steps and the 4 sources of evidence to look for what works and what doesn't work. I would like to stop here, and if you have any questions, you can always email me. I'm sure you will have lots of questions. This is my email address, and thank you very much for listening.
Thank you so much. We do have about 5 or so minutes for questions. If anyone does have a question, you can feel free to chat it in the box, or you can also take yourself off of mute and speak up as well.
I don't think there are any questions for me. I'm just checking in the chat.
Yep, it seems like not. But if folks do have questions,
this is Robert.
Oh, great.
I'll ask a question if I was letting other people speak up if they were doing that. Can you say something, Doctor, about how do you sort of quantify, the somewhat subjective evaluation of the quality of who is doing the research and how thorough the paper was, versus just being on a site? I just wonder, because like one of the things that's come up with Facebook and social networks is if things are entirely self-referential, if there's value in gaming the system, if you're somebody who's trying to push a certain point of view, then you can sort of figure out a way to effectively get higher reputation on many of these systems. And what does EBB do to avoid that? Yeah, so that's a very, very good question. Well, first of all, there are 2 things.
not all research that is written up is good quality. We know that some research studies are full of flaws. Some research studies lack a good methodology, the conclusion, the outcomes. So first of all, not all research is good quality. Sometimes not so good quality research gets into a journal and publications, and sometimes not so good quality research gets into it, and sometimes even the good quality research doesn't get published. So that's one thing. The second thing is the peer review process. It's better, but it's not perfect. It gives some rigor, some robustness to your argument. The fact that you have conducted a scientific experiment and you have published it, has gone through reviews, some independent blind reviews. I think it gives some rigor and some objectiveness to your idea and experiment. Now, your question about how do we link this to, in terms of whether this research is actually making an impact, it's a very good question. Very recently, I've come across this this portal called Dimensions, and I would recommend you to look at it. And what it's doing is actually linking the published research work to what impact it's making in terms of whether it is cited by a policymaker, by government, in terms of government reports. So it's a very, very good portal. It links research all the way from publication to whether it makes an impact at a national level, at a policy level. It's called Dimensions. Really good website. I would recommend you look at it.
Great, thank you.
Great. Does anyone else have a question?
Robert, this is the one. Let me just show you the there. That's the one. Can you see it?
Yeah, you are presenting that now. Absolutely. Okay,
so
great.
Our,
yeah, that's a good link. Thank you.
Great. Thank you so much, Doctor. So we'll now hand it over to Dr. Drost to give us his presentation on Beyond the Beacon Chain. So Dr. Drost, I'm going to hand it off to you.
Okay, great. Let me get this pulled up. Show this window. Okay, so you should be seeing the title slide. eea-eth Beyond the Beacon Chain. Let me just get a confirmation, Christine, that you're seeing that.
Yes, I do see that. And I'm not sure if you're in presentation mode or not, but we do see
I'm not. If you don't mind, I have a little bit of a problem. I'm on a 40-inch screen, so if I go to presentation mode, it might make GoToMeeting barf. So I'm going to leave it in this mode. I'm using very big fonts, and as a bonus, people can see the slides coming up. So
there you go.
Okay,
that sounds good.
So this is going to be, obviously a little bit of farther out, yet hopefully not too far out of a little preview of what's going on for people to catch them up on Ethereum 2. I know because I've been at EEA calls and so forth. Most people in this community are, of course, very focused on, what is real now and what, we actually can be doing in, pilots and POCs and even production. So eea-eth is a little bit of a ways off, but hopefully this is a nice little catch up. And there's also links at the end of these slides to give people an opportunity to read more and also to connect to various channels if you want to get further updates. The other thing is you'll see there I have my email. Feel free to reach out to me. I also have my Twitter handle there at RJ Drost. And after this presentation, I'll go ahead and I'll just post these slides to Twitter. So feel free to take a look there if you want to download a copy of those. Okay, so first of all, I think what's helpful is to just do a little step back here, and rather than jumping right into eea-2, let's just talk about some of the relevant properties of Ethereum 1. And I'm highlighting some of the things that are going to be changing, as you'll see here. One of the key aspects that has caused a lot of issues in Ethereum 1 has been, and in general blockchains, has been this idea that the transaction format, the way state is represented and managed through the state transition function from block to block, is all hard-coded in Ethereum 1, as it was with pretty much all of the blockchains of that generation. And then the other aspect was that things were very linked, that if you were a consensus provider, so if you were providing economic security through proof of work mining, or in the future in Ethereum 2, it'll be proof of stake, or in BFT through your reputation, you know, with the other people that are in your permission blockchain, you have to maintain the full state, and you have to execute all of the transactions in order to also be providing that security. And so those things sort of are all, you know, from a computer science perspective, you can see they can limit scaling and give you a more limited flexibility. In Ethereum 1, there's been a lot of challenges. There's been great, I mean, people have actually done hard forks. There's been an EIP process that's, you know, frustrated some, but good things do make its way through the process. But still, having a lot of things, we just know from first principles that, you know, having everything coalesced into one system that's all interdependent and needs to be upgraded lump sum is always a challenge long term. And there goes my hard forks. You know, any changes to the consensus rules, to the state transition function, to how you represent state basically, and what executions represent as far as changing one state to another one, requires a hard fork, and that's been, you know, the tough part. We have had them in public Ethereum, but, you know, they're sort of a very strongly orchestrated process. And you'll even notice when you look at gas prices, you know, gas prices for Ethereum 1 have come down a lot. In the last year, I think I did a check of 2019 versus 2018, and I think the cost of gas on average has been about 1/4 this year of what it was last year. But it still had a spike around the hard fork. I think it was Constantinople around February, March timeframe. And I think it went up like 20x that day or so. So there's always a lot of uncertainty around hard forks inherently. Okay, so in Ethereum 2, I'm going to hit these points a couple of times in this presentation. So, you know, excuse me that I'm just sort of putting the words down here, because I, you know, unpack these a little bit, you know, a lot more as we go through the next 20 slides. But basically, the key concept of Ethereum 2, obviously everybody hears about Beacon Chain a lot because that's what everybody's been focusing on as far as the economic security of the proof of stake mining, which is, you know, absolutely key. But from a developer standpoint, and I come at it much more from, you know, I have a lot of interest in the research at layer 2 where the dApps are existing, and at the privacy layer and the identity layer and so forth. You know, proof of stake or proof of mining is sort of far below where the application is. You count on it, it's really important that it's there, but what does it actually look like to write smart contracts, and what does it look like to interface those smart contracts through some JSON RPC to the rest of your application that's not on the blockchain at all? And so in Ethereum 2, the key concept here is that rather than essentially everything being a fixed layer, there's been a lot of effort to split things up into a minimal fixed layer, which does require forks to change, and then having a very flexible kind of, in a sense, runtime, if you want to call it, or another way to think of it, I'll kind of talk about that in later slides, a new contract layer. So it's not smart contracts at the dApp layer, but it's a execution contract layer that's introduced that actually defines what is state, what are transitions, what is the state transition function, how do people validate the state transition function. And it really moves a lot of the heavy lifting away from the economic security layer, the proof of stake layer, to higher layers, which are flexible and which do not require forks to change. In fact, you can just keep creating lots of new execution layers as you go. So, I mean, I really do want to give, I don't want to, give a diminished role to the fixed layer here. It's absolutely critical. And for Ethereum 2 and the public side, I think the real, one of the biggest values here is just how much careful work has been made at the beacon and shard proof of stake protocol layers. And part of the reason it's taken an extra 2 years or an extra year and a half to really get Ethereum 2 moving was that the researchers had a number of starts and then stops where they realized things were not as secure as they wanted. They went back to the protocols and then reworked them. Ben Edgington has done some posts in the past about the sort of history a number of people had in 2017 and 2018, what happened. But at this point, the beacon and the shards proof of stake protocol, I think, is considered to be pretty well fixed. And in fact, there's a test net that the eea-eth and I think as many as 8 clients are looking to participate in by the end of this year, early next year, which will be a test net for the beacon and the shards. It won't be doing execution. It'll just be basically showing that the proof of stake protocols are stable and scaling, and that all of the cryptography and everything necessary and all of the messaging is working, in fact, for that. I should also say at the fixed layer, it's not just the POS protocol. There are 2 other key things that are at the fixed layer. There is an actual protocol for executing ETH transfers that can't be left up flexibly at the most fundamental level because of how important economically transferring around the real digital currency is. So there's 2 types of transfers that are defined. One is from these flexible execution environment layers to the beacon chain, back and forth, either direction. And then the other one is from one execution environment to another execution environment. So that protocol is actually defined, and it would require hard forks to change. And then the final fixed layer is there is a new contract layer, which is, if you want to think of the consensus layer in a kind of Ethereum 1, we called consensus layer, or what's on blockchain layer 1, and we called things that were sort of flexible layers like Plasma layer 2, or things that were in dApps were layer 2. And so that dApp layer of layer 2 is now this, flexible EE layer. And so the contracts that actually define the execution environments, they're a new layer somewhere between what used to be layer 1 and layer 2. So you can sort of think of it as a new layer 1.5. But it's not layer 1 and it's not layer 2. It's in that region between the 2 of those, leveraging some of the fixed constructs from layer 1 to allow there to be a layer 2 that's flexibly defined. And then finally, the execution environment layer, it defines what is the transaction. What's really exciting, I'll go through this in more detail in some later slides, but like Ethereum 1 is a state transition environment with state. Clearly, there have been other blockchains. Bitcoin used a UTXO model. There have been ideas around putting zero knowledge fundamentally into the blockchain and DEXI-style models, and so forth. All of these are completely definable as EE layers, which I think is really exciting. Obviously, in the EE layer, what is the state, if any, is defined in a UTXO model. There's no real state outside of what you actually read on the UTXOs themselves. You certainly can't call a contract again and assume there's any hidden state. Everything is actually written on the blockchain itself in the UTXO transactions. And then how to execute and validate the block-to-block state transition is also being defined. So as I said, I'm going to sort of hit these themes a number of different ways. So here's another pictorial view, just if you wanted to capture a picture, this is a good one to just keep in mind. The phase 0, which is the first phase of Ethereum 2 development, if you're aware of it, that's entirely fixed. That's the beacon chain. Phase 1, where the beacon chain interacts with the 1024 shards. A number of components of the shard protocols are completely fixed. However, the shards are actually where that layer 1.5 execution environment contract layer is running. And so the shards do have a certain amount of flexibility to them because they are actually running WASM code that defines the EE layer. And then finally, phase 2, the execution layer, the current indication is that the EE layer is, we're looking at it as being essentially a completely flexible layer. There are a few caveats there around who is controlling the state and how you get transactions onto the blockchain. But we'll see if we actually even hit those in the talk. They'll be in the backup slides when you download them and in the source reading material, but it can get a little much in a 20-minute presentation to present all of it. So we'll see if we get to that. So just quick recap, phase 0, beacon chain, in case somebody hasn't seen, the joke we say is one ring to rule them all, and in darkness we bind them. So the beacon chain is where all the validators and all of the shards, even though they only have local state for their shards that they're maintaining and that they're doing consensus over and economic security, the beacon chain effectively fuses the security of all of the shards together into a super security among all of them. So it does a tremendous amount of beautiful things. It's really a research tour de force. I welcome people, if they haven't looked at it yet, to take a look at it. I do have a question. I wonder if anybody's going to ask it in this, if we have any BFT consensus people. I am interested in what EEA mindset people are thinking is going to be how public versus private permissions is going to look for Ethereum 2 type blockchains, but let's leave that for the Q&A later. Phase 1, of course, I mentioned before, the shards. You can see in this picture there, around the middle, that blue and yellow is the beacon chain, and then it's pointing to all of the shards that are, in fact, progressing individually, but referencing back to that beacon chain. And state execution, that's what I'm talking about here. In phase 2 is the utility aspect. And, obviously, economic security is very high utility. I'm just referring to the fact that from an end application standpoint, the interface is, at this phase 2 layers where your applications will be pointing. Okay, so now I'm going to focus the rest of the talk just on these execution environments. And the first one is, and I like to just ask and try to see if I can make a reasonable answer. And I vetted these with a number of very knowledgeable people. In the research group, Consensus has a hub R&D group that's heavily working in this space. I'll talk about it at the end, where you can look to see what's coming out of that. And obviously, the eea-eth is doing a lot of work. Other parts of Consensus, like Pegasus, have done a lot of work, obviously, on Ethereum 2 with the Artemis client. But there are another 7 large efforts that are going on throughout the community in Ethereum 2 as well. So what is an execution environment? So I've vetted with some of the people in those environments, and these are generally correct sort of statements here. So an execution environment, as I said before, repeating this sort of emphasis here, an execution environment accepts the consensus rules, the fixed rules of the beacon chains as the shards, and the shards as they are, and but accepting those fixed rules, it does allow you to define a very critical aspect, which is the state transition function. So what is the way that you move from one block to another block at the execution layer? Not surprisingly, it's defined in WASM, and there's a key point here is that it's a pure function. I'll show you what a pure function is for people that aren't completely familiar with that concept there. The key idea is that there's no state inside of the function. So it accepts a pre-state root and an input block data, the transactions and data witnesses. If you haven't heard the phrase data witnesses before, just think of numerical proofs effectively. So a bunch of data objects like variables and values, and then the proof that shows against a state root that those are actually the values at some past point in time. And the pure function then returns the post-state root after executing the block. So it's completely stateless. So the execution environments, they're expensive to deploy. We don't know how expensive they're going to be. Vitalik has said statements of like hundreds to thousands. It may be variable. If you deploy more expensive execution environment contracts, it's a lot more expensive. It's not too surprising. On the one hand, we've had people say they should even be more expensive because, in a sense, the state function that's being represented by the execution environment and EEs in general are trying to capture the execution protocol of the full blockchain. So, obviously the fixed layers they can't reconstruct. So like when I show Hyperledger Fabric, I'm not talking about, changing the consensus layer, but if you want to talk about what is the smart contract layer of Hyperledger Fabric, or a Bitcoin or Ethereum or a sovereign identity layer, Hyperledger Indy, and so forth, how do you actually execute contracts? How do you hold variable state? How do you have contracts call each other and so forth? All of that is defined at the EE layer. Okay, so pure function, here's actually a definition of the pure function. And, the key concept here is that there is nothing hidden inside of the state transition function. Effectively, you're calling the state transition function as an entirely fresh instance each time it's being called. There is nothing that's, there's no one that you're referring to in the past, from the past. It's just a block of code that's being called. So everything that's necessary is being passed in the block and in the pre-state data witnesses. And there's a pointer down there if people are interested in what this pre-state looks like. They're called, I think, simple serializers is one of the protocols for that, SSEs, if you've been seeing that discussion going around that ETH research. So just hitting these themes one more time from another viewpoint, the state update in Ethereum 1, the reducing function, was hard-coded. So everything that's in this diagram is effectively written in whatever language an Ethereum client is written in. It's written in Go, it's written in Rust, it's written in Java. And if you're going to change any aspect of the reducing function of what is state hash, you're going to have to get all of the clients to agree and change in their native languages what the operation is. So that's why it's been so heavyweight. So when you contrast that with Ethereum 2, this is instead the picture. So think of S and P and Q as three different execution layers. I'm labeling them S as being like an Ethereum 1 style execution layer. So it has smart contracts, it has state. It will be expanded versus Ethereum 1. If you're going to do an Ethereum 1 like protocol in Ethereum 2, you're going to probably allow you to have cross-shard calls so that you can actually have higher throughput than Ethereum 1. But, there is talk of Ethereum 1. The simplest version of just moving Ethereum 1 to Ethereum 2 is just, write it in WASM and just put it on one shard, lock it to that one shard, and don't allow cross-shard calls. So it could just be simply almost exactly Ethereum 1. P is the UTXO style, Bitcoin style execution layer, and then Q is an example of a ZEXI. And what I'm showing here is the beacon chain at that 1.5 layer has these contracts which are defining the Ethereum 1 execution environment, the UTXO execution environment, and the ZEXI one as well. And they're being called, those arrows that are pointing down from those contracts are in effect being run by the shards as they're doing the state transition functions. So the only fixed thing really is inside of the beacon chain. It's, the rules for defining those contracts. So you can load up new contracts anytime that you wish. Of course, let me just note one point here. The focus reader would sort of notice these are contracts in the real sense of like Ethereum 1. So they are not versions, they're not modifiable. So there is a whole bunch of interesting questions about upgrading. Vitalik and others have talked about that, you would want a upgraded Ethereum 1 EE if you're doing an upgrade to allow you to sort of pull the state from one contract and then move it to a new one. So there would actually be, in effect, forks at a given execution layer as you're upgrading them. But it's not changing the beacon chain in the fundamental Ethereum 2 protocol. It's basically limited to that one execution layer. So, it's not like magically all problems are solved, but we're sort of limiting the sphere of what's being influenced by the need to fork something at the UTXO layer to not affect Ethereum, an Ethereum 1 execution layer, or Ethereum 2 execution smart contract layer, or ZEXI, or so forth. So here's another slide, which hopefully people have, I've been saying this a few times now, but let me just say it explicitly here on the slide that an execution layer is not exactly an Ethereum 1 smart contract. It has certain properties. It is immutable. It is written in WASM, so it'll be very similar to an Ethereum 2 WASM contract, but it is defined and run at a different layer. In a sense, in like a Unix sense, an EE is kind of much more like a kernel process versus, you know, a smart contract is much more like a user level process. So the EEs are executable, excepting the fixed layer operation, of course, of ETH2 at the beacon level, beacon and shard levels. And it's a definition of what is a blockchain, what are the transactions, the state, and the transition function. So why are the EEs valuable? And, you know, this is a good question to sort of ask. It's very, I mean, you don't hear this all the time. When a researcher gives a talk, they'll sort of just run right into what it is and how it works, and sort of left to the reader to sort of state this. I'm just sort of putting my view. This is, you know, everybody can take away their own points of view, but this is Robert Drost's sort of point of view. Now, when I looked at, I mean, part of what got me excited about Ethereum versus the rest of the blockchains, if you look at the second statement there, you know, Ethereum 1 abstracted the fixed semantics of digital tokens. I mean, in a sense, it's a full Turing machine. It could have abstracted everything, but really abstracting everything, you know, is computationally, storage and bandwidth-wise very expensive in Ethereum 1. But Ethereum 1 worked really well for abstracting the semantics of digital tokens and things that are fairly close to the transaction, low compute, low storage, cost layers, so that currencies and early blockchain, Bitcoin type blockchains, instead of proliferating to be 1,000 different, slightly different protocols, they all collapsed onto Ethereum 1 as smart contracts that could be explored. So Ethereum 1 had a tremendously valuable place. Ethereum 2 has kind of recognized there's been a lot of work by, you know, Parity, Polkadot, and, you know, Cosmos and in Tendermint and others of like trying to allow there to be flexibility at the execution layer that's separated from the consensus layer. And a lot of people are kind of focused on that. Even people who focused on privacy, if you followed Oasis Labs, they kind of cite how important it is to have execution as separated from consensus as possible. And so I think the Ethereum 2 researchers really recognize that and then look to see, you know, because they have that bent in the eea-eth so strongly of how to do things as decentralized as possible. How can we go ahead and actually make an Ethereum 2 offer as much value at the economic security layer, you know, by having people stake real, you know, real ether that gets slashed if they do bad things, but not have the people that are doing that economic security get bogged down with, you know, from a performance level, having to actually run the execution layer and all of the components of it. And then from an upgrade aspect, to not cause, you know, ossification of the entire blockchain, because it's just hard to coordinate getting X clients written in different code bases to agree with exact, you know, bit by bit, byte by byte exactness on upgrades, hard forks to the blockchain. So that's a really valuable aspect of EEs. Another way to look at it, I mean, this is the second, you know, the sort of corollary of that axiomatic goal of EEs, which is, you know, the beacon chain's job, if you want to think of it, is to just, and I put that in just, to, you know, basically build a worldwide decentralized network of trustless, you know, interested but non, you know, coordinating or non-friendly actors that are yielding tens of thousands. And I put that to start. I mean, if you look at Ethereum's at 12 to 15 transactions per second. So 1,000 plus shards to get us to tens of thousands of transactions per second. In reality, the EE layer allows us to be a lot more flexible about how much state we're holding and We can do simplifications of the validation function to kind of collapse how much is actually being done even at the shard layer. So there are people that are kind of whispering of like, we probably can do additional 10, 100x type improvements over time. But let's just start off with the tens of thousands to start decentralized transactions per second, which is already great. And the EEs effectively enable that TPS level to be shared among many different program execution layers of a multitude of blockchains. And that's a very strong statement. I mean, if you think about it, you know, on the one hand, you're providing a lot of value that you're having tens, hundreds, any number of different blockchains that are utilizing this core layer, and they're not utilizing in like Plasma in a very slow block by block, you know, secondary level sense. They're actually utilizing it at the beacon chain level. And on the flip side, from an economic security standpoint, this allows Ethereum 2 to coalesce the monetary incentive security of people on many different blockchains into one base layer. And so it sort of gives me the hope that Ethereum 2 is going to have a much higher security bar than Ethereum 1, and I'm hoping even a much higher bar than Bitcoin in order for people to attack it on a minute-by-minute, hour-by-hour basis. And there I talk about the economic security of like, how much money does somebody have to burn in order to actually be attacking the proof-of-stake consensus protocol versus Ethereum 1 proof of work and Ethereum and Bitcoin proof of work. Now, this is sort of maybe, this is an information meeting for EEA. I don't think people on this are necessarily going to be building EEs, but I put this question up there because I've given this talk at developer conferences. If you're a core developer, if you're contributing, and if you're interested in contributing to public infrastructure of Ethereum, then of course you should be thinking about building an EE or contributing to other people building EEs. If you have an idea that once you understand EEs only makes sense in an EE, needs higher performance levels, then you can be getting just at the single shard layer or at the dApp layer, then you might actually be hand-in-hand building your dApp layer as well as the layer that executes the dApp layer. It's a new abstraction you have available. And, you know, that's the question of will your application benefit from this two-layer contract hierarchy? And so what if you only build dApps? So on the one hand, if you only build Ethereum 1 style dApps, there will be as smooth as possible of an on-ramp for Ethereum 2. There'll be an Ethereum 1 model, EE probably, and as well as an ETH2 one that adds cross-shard state transfers. And your dApps will be faster and execution will cost, you know, less, far, far less, both because of proof of stake being much less expensive than sharding. But you may get left behind if you don't learn to leverage the new infrastructure. So that's always the value. And I do want to give people an opportunity to sort of ask questions. So I'm going to just leave these example EEs. Feel free to go and grab my slides and take a look through the points on them. But I've got 5 here, including the move EE from Facebook Libra could be on Ethereum 2, delayed state execution if you're familiar with Haskell and those models, verified claims EEs for identities, rollups, all of that can be on there. The last thing I just want to mention before I open up for Q&A is there is a test net that Hub R&D, the group that I'm working with the consensus, is actually putting together. It's a simulated beacon chain, so it's not like the test net for the beacon chain. It's not actually running the beacon chain protocol. It's simulating that layer, so it's a centralized beacon chain simulation, and then it's running 8 to 16 shards on top of that to allow there to be some cross-shard interactions. And I have links here. Feel free to take a look. The top one there, learn and contribute, the Hack MDIO, that has pointers to everything. There's a Telegram channel that you can learn more about. And then Ben Edgington from Consensus recently did a good post on YouTube to catch you up as well. And I should mention that the Quilt team, that's what the name is of the project that's doing the testnet for phase 2. They're heavily collaborating with the Scout team from the Ethereum Foundation. Scout is the eWASM runtime machine for Ethereum 2. And it's being implemented first in Lighthouse, which is a Rust client, but of course it'll be open, and hopefully we'll have a number of other clients start using that as both an interop and as an DApp testnet layer for phase 2 in the future. And, you know, final takeaway of like why this phase 2 testnet is exciting is that, you know, we kind of recognize from the beginning of this year when EE started first crystallizing to now, we've gone from there being the idea that execution to phase 2 was going to follow on the beacon chain and shards to effectively now we've kicked off the work on the testnet of the phase 2 execution in parallel with the beacon chain testnet that's going on. And so I show it as like fairly lining up well, that the goal is to actually have, for people that are looking to both beacon chain and shard testnets that are accurately getting the decentralized nature of that layer, those layers, and then having phase 2 that's doing at first the simulated layer of the beacon chain and shards, but execution-wise allowing EEs to start being testnetted by early next year as well. All right, I'll open it up for a quick question or two. And I don't actually see the chat layer, so Christine, feel free to jump in if you see any chats.
So far, yeah, so far no chats yet, but if folks do have a question, feel free to chat that in the box, or like I said, you can take yourself off of mute and ask Dr. Drost your question directly. Ken, it looks like you have a question. And Kumar, do you have a question? Okay. So for folks who have questions, you are on mute. So Kumar, I've unmuted you if you'd like to ask your question.
I just wanted to find out, how do we access the slides in the presentation?
How do you get a copy of the slides?
Yeah.
Yeah, so I'm going to post them in after this meeting now on my Twitter feed, so at RJDrost. So
can you put your handle on the text on the text?
I'm sorry?
Can you put your Twitter handle on the chat?
Yeah,
yes, I just put that up there. Yeah. Great, thank you.
Okay, and there's some bonus slides. If you do go download them, you can see them on the left side appearing here. I didn't talk about it, but there's some interesting stuff on asynchronous cross-shard transfers as well as the stateless aspect of this. So there's some really cool stuff in there.
And it looks like we do have, if we have a moment, we do have a question from Ken Fromm. And Ken, I've unmuted you. So go ahead and ask your question.
So the question is, what throughput is being discussed for ETH2?
Yeah, so the initial thought is an ETH1 style environment running smart contracts should be getting into the low tens of thousands of transactions per second spread across the shards. But the really interesting part with EEs is that there's been a lot of work on ZK rollups. There's been a lot of advances even on the UTXO model for Bitcoin, as well as how to do simpler data availability. And then ETH2 already is sort of separating out the state from the consensus layer. So a lot of the heavy lifting is being done before it gets to the beacon chain. So the thought process is that there's, versus ETH1, where things basically from a TPS layer just remain fixed. In ETH2, we're going to have the initial launch, which is going to be, 1000x ETH1. And then there's going to be at the execution layer, there'll be advances where we should see a steady progression of TPS increasing, on a quarterly basis or at least yearly basis.
Great, thank you. And George Polzer, it looks like you have a question. I've unmuted you if you'd like to ask your question.
Sure. I've tried to understand what the WASM is all about, and can you explain the importance of it, or the role it's playing that makes it that changes the Ethereum 2?
Sure. I mean, I didn't talk a lot about WASM here. It ends up that EVM and eWASM they're important in the sense that you want to have a standard large environment. You want to have a lot of tooling around the base virtual machine, bytecode, interpreter environment, or potentially compiler environment. But from the perspective of consensus and the perspective of the smart contracts, it actually is not that big of a factor. What is the runtime environment itself? So the reason I think why EVM was, kind of left behind and there was the move to WASM by the Ethereum community wasn't so much that EVM is terrible. EVM, especially if it's written well, can actually be a fairly fast virtual machine layer. If you're familiar with the work done on TurboGeth, in the last 9 months, you'll see that there's been a lot of advances. Part of the reason EVM looks slow is just the implementations weren't very, performance focused. But really, the move to WASM was more driven by the idea that because the browsers and the web ecosystem was moving to WASM, it made a better sense long term in terms of having a lot more people looking at it. I mean, even if you look outside of the DApp side, if you look on the auditing security side, formal verification, formal security, there's a lot more incentive for that ecosystem to work on WASM than on EVM because it's applicable to everybody using that. I hope that sort of answers that. That's part of the reason I didn't highlight a whole lot of WASM there. It's definitely something that's in Ethereum 2, but it's not the most critical aspect. It's sort of a black box. If you talk to Vitalik, just kind of talks about it that way. It's just a black box for the VM that's different from EVM, but not critically different.
All right, thank you.
No problem. Good question.
Great. It looks like Ken, did you have one more question?
No, I didn't. I'm good. I just wasn't sure how to use. I typed the question in the box and thought it would appear, but it possibly didn't. So.
Got it. No worries. Excellent. Okay. Well, thank you everyone for attending today's education series, and we will see you next month.
Thank you. Thank you very much.
Thank you.
All right. Thank you, everybody.